Have you ever wondered what actually happens when you start your car? You turn a key or push a button, and suddenly everything roars to life. But under the hood, a mechanical miracle begins. Inside that engine block are small chambers where mini explosions happen over 100 times per second. That's right, your car runs on controlled fire. But how does exploding fuel make a car move? In this video, we'll break it down step by step. From the intake of air and fuel, to the spark that triggers combustion, to the pistons and crankshaft that turn explosions into motion. We'll also cover how your car stays cool, lubricated, and why timing is everything. Whether you're a student, a future engineer, or just a curious car lover, by the end, you'll understand exactly how car engines work. Let's open the hood and dive in. At the core of every car engine is a powerful reaction, combustion. This is when air and fuel are mixed together inside a small chamber, the cylinder, and ignited by a spark plug. That spark causes a small, controlled explosion that pushes a piston downward. This motion is what eventually drives your wheels. But here's the crazy part. This happens in each cylinder dozens of times per second, and your car has multiple cylinders working in sync. The air-fuel mixture has to be delivered at the right moment, and the spark has to be perfectly timed. If the timing's even slightly off, your engine loses power or efficiency. This is why modern engines use computers to make tiny adjustments in real time. In short, fire plus fuel plus precision equals motion. That's the heartbeat of your engine. Now, let's talk about how that explosion happens step by step with the four-stroke engine cycle used in most cars today. First is the intake stroke. The intake valve opens and the piston moves down, pulling in a mix of air and fuel. Next, the compression stroke. The piston moves up, compressing the mix to make it more powerful. Then comes the power stroke. The spark plug fires, causing an explosion that pushes the piston down. Finally, the exhaust stroke. The piston rises again, pushing out the burnt gases through the exhaust valve. Then it all repeats over and over, hundreds of times per minute. Every cylinder goes through this cycle on its own timing. This system is what makes your car engine a precise and efficient power machine. It might sound complex, but it's all just an elegant loop. Suck, squeeze, bang, blow. That's the magic of the four-stroke engine. Let's connect those explosions to your wheels. The star here is the piston. When an explosion pushes it down, that linear up and down motion needs to be turned into something useful, rotation. That's where the crankshaft comes in. It's connected to each piston by a rod. As pistons fire and move up and down, the crankshaft spins, and that rotation is what gets sent through your car's drivetrain, eventually turning your wheels. To keep this motion smooth, engines are designed so pistons fire at staggered times. While one is exploding downward, another is returning upward. The timing belt or chain ensures that all the parts move in perfect sync: pistons, valves, crankshaft, and camshaft. Without that synchronization, the engine would destroy itself. So next time you accelerate, just remember, your wheels are spinning because a piston just got punched by fire. How does the engine start in the first place? When you turn your key or push the start button, the starter motor turns the engine over for just a second. That motion is enough to begin the combustion cycle. After that, the engine runs on its own, powered by its own explosions. But there's more. Modern cars use an engine control unit ECU, a mini computer that controls how much fuel goes in, when the spark happens, and how the engine responds to things like temperature or load. The ECU reads data from dozens of sensors: how hot the engine is, how much air is coming in, how much oxygen is in the exhaust, and more. Then it makes real-time changes, adjusting timing, fuel, and airflow for maximum performance and efficiency. Your engine isn't just mechanical, it's smart. It's constantly adjusting itself, all while you're just driving. An engine running thousands of tiny explosions per minute gets incredibly hot. Without cooling, it would overheat and destroy itself in minutes. That's why your car uses a cooling system, with coolant fluid, a radiator, thermostat, and fan. Coolant circulates through the engine, absorbs heat, and releases it through the radiator. But heat isn't the only enemy, friction is too. That's where engine oil comes in. Oil lubricates moving parts like pistons, bearings, and valves, preventing metal-on-metal damage. It also helps carry heat away and keep everything running smoothly. If you've ever heard someone say change your oil, this is why. Old oil can't protect your engine. Together, coolant and oil are like your engine's immune system, keeping it cool, smooth, and protected at high speeds. Forgetting them is like running a marathon with no water and no shoes. So let's recap. Your car engine is a controlled chaos machine. Air and fuel are sucked in, compressed, ignited, exploded, and that explosion pushes pistons that spin a crankshaft that moves your car. All of this happens hundreds of times a second, while staying cool, lubricated, and perfectly timed. It's a mix of chemistry, physics, and brilliant engineering. And the fact that most of us use one every day without thinking about it, that's even crazier. Whether it's a 4-cylinder or a V8, a gas engine or hybrid, the science behind it is the same. A machine built around fire, force, and precision. If you want to know how electric engines compare, drop a comment. And if this video taught you something new, like, share, and subscribe for more real-world science made simple.
Ordinary people join